All right, hello. I wanted to go over this quiz. Make sure you watch it before the test this Thursday. So we're going to find the vertex of these parabolas. Well, this parabola is already in transformation form, I guess. So this indicates that you went left 6, and this indicates that you went up 10. So the vertex is simply negative 6, 10. Over here, you can add 2 to both sides. And here there were no movements left or right. This 1/3 indicates that there was a vertical shrink of a third, and this goes up 2. Another way to look at it is like this. This is the same thing. So this tells you that the x part of the vertex is just 0. It didn't move left or right at all, but the y part is 2. If it's not in transformation form, you have to do a little bit more work. You have to do the opposite of b over 2a. So in this case, it's negative 8 over negative 4, which is 2. That is, we just found the axis of symmetry, but that is also the x part of the y-intercept. I'm sorry, the x part of the vertex, the x part of the vertex. So now I need to find the y part of the vertex. And I'll just do a little synthetic division here. So it looks like the y value is negative 3. This is using the remainder theorem. The domain for all parabolas is always all real. The y-intercept is, of course, negative 11, 0, negative 11. The range, well, the a value is negative 2. So that means this parabola is facing upside down. So it has a maximum. So that means the y values begin, I guess, at negative infinity, and they go all the way up to the greatest y value, which is negative 3. Create a quadratic function that has a range of negative infinity to 19. So right away, negative infinity to 19, that would do it. Because the minus sign makes it upside down, and 19 is the highest y value. But the vertex is in the second quadrant. Okay, so second quadrant is right here. So I need this vertex is at 0, 19, and that is on the y-axis. That is not on the second quadrant. So I just need to shift it to the left a little bit. So this is one possibility. The negative faces it upside down. The plus 4 moves it to the left 4. And the plus 19 moves it up 19. So that this vertex is negative 4, 19. And since it's negative, it's facing down. And you can see that the range is from positive 19 is the largest y value. And the y values go down to negative infinity. In this polynomial, this is the dominant term. So as x gets really, really big, what is happening to the y values? Well, a really, really big number raised to the 6th power and then multiplied by -1 makes it really, really small. So the y values become really, really small. When x approaches a really small number, then if you small number like -1,000,000, again, raise it to the 6th power, it suddenly becomes positive because all those negatives cancel out. But then you multiply it by that -1, it becomes negative again. So this one falls to the left and falls to the right. So for here, this polynomial, it passes through, -2 is a 0. My computer stalled.